All right, let's go ahead and go over the quiz 1 here. So this is the key. Whenever you do a quiz, make sure that you read the questions thoroughly. So, for example, if the question is saying put things in scientific notation, such as that, make sure you follow those directly. This question is simply asking you to identify the number of significant figures and place them in the spaces provided. So the first one, how many? 5. There are 5. And then B, how many are there?
4.
There are 4. Remember that one of the benefits of scientific notation is that the numbers in front are all significant. So you just have to count those. Don't worry about the 10 here. That is your exponential and multiplier. Next one here.
6.
There are 6. So when you have these trailing zeros here, remember those are not placeholders. Those are significant. And they're after the decimal there. However, in D, we do have placeholders because they're before the non-zeros. So how many sig figs here?
4.
There are 4. All right, and then the last one here, how many?
7.
There are 7, yes. All right. So the next one here, you have any questions about this one? Any of them? The clear? All right. So the next one here, we need to do the calculations, and then you need to apply your significant figures rules as you go along. So I'm going to go ahead and use my calculator. You guys aren't allowed to use your phone on the test, but I can use them, right? It's the benefit of being the teacher. You get to use your phone on stuff. All right. So the first question here, I need to go ahead and do a subtraction. So we have 16.331 minus 12.2. And my calculator is saying 4.131. All right, so should I go just default to 3 sig figs, or is something else I need to do? So what determines the sig figs here when you're doing a subtraction? Number of decimal places, right? So this number has 1, this number has 3, so our final answer should only have 1 decimal place, so 4.1. All right, let's take a look at part B. So here we need to follow the order of operations. So I like to just go ahead and do it a step at a time and then keep track of my sig figs as I go along. So looking at this here, what should I do first? Which exponent?
Inside.
The one that's in the parentheses, right? So 5.0 squared. So let me go ahead and rewrite this. So it's 12.345 plus 5 squared is what? 25. And how many significant figures should that number have?
2.
Should have 2. Yep. When you're doing a square or anything to a power, you're technically doing a multiplication. So make sure you keep track of that. There should be 2 sig figs in this answer here because we had 2 here. All right, don't forget we have that cube term. All right, next I'm going to go ahead and do the addition. So 12.345 plus 25. And I am getting 37.345. So here, let's go ahead and rewrite this number down here. Remember, no rounding till the end. And following the addition rule again, how many significant figures should this number have? 2. Should have 2. Yep, so we have no decimal places here, 3 decimal places here, so we get 2. All right, and then without clearing my calculator, I'm going to cube this term. I like to use the little caret keys right here on my calculator. So caret 3, and then I'm getting a fairly large number there. But the question is, how many significant figures should my number have?
2.
Should have 2. So I want to go ahead and express this in scientific notation because it's a pretty large number. So I'm going to write it as 5.2. So we have the 2 significant figures times 10. And then what power should I raise 10 to? 4. All right. Next one here. We need to do the cube term first. So 4.211. I'm going to cube that. And let's write it down here, 74.671, blah. Because we know it's not going to go that far down anyway, so I just put the dots there. How many sig figs should this number have? 4. We had 4 here. We're doing a multiplication. So let's go ahead and keep track here. We should have 2 decimal places. So then go ahead and add the last digit. And I get 97.77, etc. And how many decimal places should I have? Should have 1 decimal place, so I'm going to go ahead and write my answer as 97.8. You could have went ahead and put it in scientific notation. I don't think the question was being specific about that, so here we go. All right. Backing up a second to this one, I actually prefer to put these in scientific notation because you don't have the ambiguity of all the 0 placeholders. Here you're just really clear on what your sig figs are. All right, next one here, we need to follow the order of operations. So I want to do the parentheses first. So let's go ahead and take 4.53 plus the 6.51. All right, I get 11.04. Let's go ahead and write this out. Minus, and then we got 11.004. And we're going to square that, but first things first, how many significant figures in that number? In this number here?
4.
Should be 4 because they both have 2 decimal places. So you're going to see sometimes when you add, you may either gain or lose depending on how the numbers work out. So if you go up in an order of magnitude or down in an order of magnitude, you may gain or lose a significant figure. So just be careful of that. All right, let's go ahead and carry out that operation. So we're going to go ahead and square it. And carrying this along, 28.8 minus 121.8816, and we should have had 4 because we're following the multiplication rule now. And I guess I could just go ahead and take 28.8 minus 121.8816, and getting a negative value does not matter. We still follow the sig fig rule the same way if the numbers are positive or negative. All right, so how many sig figs in this final answer?
3.
Should be 3, because we each have 1 decimal place of significance. So my final answer for this one is going to be negative 93.1. All right. You guys all get those? All right. So let's go ahead and take a look at the back. So here we have a few unit conversions, and as promised, I did not put a density question on there because I wanted a little bit more coverage of it before I tested you on it. And I gave you some conversion factors, once again, as promised. The ones I don't give are going between metric to the common units. There were a few that I listed for you guys that I wanted you to know. All right, so it looks like we're going to have to do a 2-step conversion based off of the units that we were given. So I think the plan should be meter to centimeter. That's the common unit here. And then we can go from centimeter, and what should I go to next? Inches. And then lastly, inches to feet. So it looks like we're going to do a 3-step conversion. One of the ones I did not give you because that was one of the ones that I wanted you guys to know. All right, so take what you're given. And I'm a fan of just writing everything out. Make sure your math is correct before you plug in any numbers into your calculator. That way, if you make a mistake, it's easy to catch. All right, so I need to go from meter to centimeter. And you remember how many centimeters are in a meter? 100. So just to keep things simple, because we're working in scientific notation, I like to write it as 10 to the 2. You could write 100, same deal, same answer. All right, next step here, I need to go from centimeter to inches. So plug your centimeters on the bottom, inches on the top. And then we go ahead and take a look at the conversion factor. and we plug in the proper units to where they belong. So it looks like the 1 should go here, and the 2.54 is there. Once again, I have not even picked up my calculator yet. I want to make sure that everything is set up properly, things are going to cancel properly. All right, and then the last conversion here is from inches to feet, and based off the conversion here, it is 1 foot per 12 inches. All right. To 34, 0.5, etc. And the units are feet. We can check our work by noticing the units will cancel properly. So we want feet at the end, so meters cancels, centimeters cancels, inches cancels. We have that left behind. All right, and how should I report my answer to how many significant figures? 4. Remember how many significant figures are in these numbers? Infinite. Those are exact numbers. So I'm going to go ahead and write my answer as all right. So next one here, we have units raised to a power. So we have to take that into account when doing our conversions. There are 2 ways to do this. One is you can jump straight from centimeter to kilometer, or you can go to the middle unit to the meter first. Because you know how we're going from a small unit to a large unit? So let me show you this real quick. So we know that there are 10 to the 2 centimeters is 1 meter. And then we also know that it's 10 to the 3 kilometer. Or is that right? Or it's meter, right? Per kilometer? Yep. Yeah, sorry, 1,000 meters per 1 kilometer. So if you were to look at that total, what's the difference between the 2? The factor of what? 10 to the 5. So what you can do as a different way to convert, it'll cut out 1 step in your calculation. It is 10 to the 5 centimeter in 1 kilometer. Once again, you also can do it stepwise, a piece at a time. I recommend doing it that way until you get the hang of doing something like this. Just make sure you're comfortable with that before you move on and that you're actually getting correct answers in your practice. And I want to try this one without a calculator, just to see if we can do our exponents correctly. All right, plugging in my numbers. And then I think I'm going to have 2 conversions, or we can do it in 1 conversion actually, based off what we did here. So it's centimeter on the bottom, kilometer on the top, and the conversion was 1 kilometer was 10 to the 5 centimeter. All right, do I need to do anything else to that? I need to square it, right? Because these units are squared. In order for them to cancel properly and give us the proper final unit, we have to square it. All right, so if you take a look at what we have here, I'm going to go ahead and write it in red. We effectively have 10 to the 8 divided by 10 to the 5 times 2. And what does that equal to? That's correct. So 10 to the minus 2. So that's one of the great benefits of working in metric, is that we can do stuff like that without a calculator, because it's all base 10. All right, next step here, we need to go ahead and convert from grams to pounds. This is another English to metric conversion. So I'm looking at my conversion here. So what do you guys think? Should I do an intermediate conversion first? So let's go ahead and take what we're given. Looks like our final answer is going to have 4 sig figs in it. All right, and then this conversion here, I need to go from gram, kilogram, and then we had a similar conversion up here, right? It is 1,000 to 1. All right, last step here, we need to go ahead and put kilograms on the bottom, pound on the top, and now we tack on the associated numbers.